Hi friends, welcome to the 8th part of nitrogen compound. In the last video, we have discussed the reactions of amine. Now let us see the sulfur drug which contains sulfur in their structural framework. So this is one of them, sulfur drug. It is a sulfur containing antibacterial drug. This is an antibacterial drug which was having very good application before the penicillin was coming to picture. This was using as the antibacterial drug. But once the penicillin comes to the market and this importance of sulfur drugs came down, and another thing, after some usage of sulfur drug, the antibacterial activity comes down because many bacteria got resistance to this drug. But still, it was useful before the penicillin comes to the market. So it was used to prevent the growth of disease-causing bacteria. Here in this structure, you can see it is having one alkyl group on the left side and one another alkyl group R dash, that represented as R dash. This R dash can be large range of heterocyclic or aromatic structures. This R dash can be any aromatic ring or any heterocyclic ring. And this R dash, which what is the nature of this group, that decides the pharmacokinetics. Pharmacokinetics means how what is the rate of introduction to the introduction of this drug to the blood, or what is the lifetime of the drug. That is decided by the structure of this R dash group. And if you change the R dash group, the applications also changes. Now we will see the preparation of the sulfur drug. It is starting from aniline. This is one of the application of our amine. So the first step is the acetylation of amine by using acetic anhydride. It is acetylating the group. In the next step, we are treating this product with chlorosulfonic acid. The first step is protection of the aniline, our amino group. This we have discussed in our reaction part. Otherwise, if you react with this chlorosulfonic acid, it will react the amino group. You don't want that. So we are protecting the aniline first by acetylation. Then you react with chlorosulfonic acid and you will have a SO2Cl substitution at the para position. Otherwise, this chlorosulfonic would have sulfonic acid would have reacted with this amino group. So we need to protect it. So we are acetylating the first step, and we get N-acetyl sulfanyl chloride. The next step, we are treating this product with ammonia, and you will get N-acetyl sulfanilamide, and finally you are hydrolyzing this product, and you get sulfanilamide. And this sulfanilamide can be used as a starting material to prepare different kind of sulfur drugs. That is one method. Otherwise, if you change the route of this reaction, you can have the desired sulfanilamide. We can change the one of the hydrogen atom here with any alkyl or any aryl group or heterocyclic ring. You get the different kind of sulfur drugs. So one way is to prepare from this, or otherwise you change the NS3 group, ammonia with any aniline in which you having an alkyl group that you want to be in the product. So this is the method. Aniline here, the same method. Your acetic anhydride you are treating with to protect the amino group, and you get an acetanilide treating with ClSO2OH, chlorosulfonic acid. You get N-acetyl sulfanyl chloride. Here, instead of ammonia, you are treating with amine or aniline, where you have different kind of R group in this, and you get the sulfur drug where the R group is present that you have selected instead of ammonia. You get the different kind of sulfur drug here. This is the method of preparation, and these are different examples. This is sulfa-pyridine, where the R group is a pyridine group. The rest of things are same. You see the structure, only the R dash is different here. Sulfa-pyridine, here you have sulfa-diazine, where diazine group is there in place of R. R dash, and this is sulfa-thiazole, and this is sulfa-guanidine. So these are the different sulfur drugs which is having various applications, and these are the important uses to treat bacterial infection like urinary tract infection, prostatitis, and bronchitis. Another application is rheumatic fever to those who are allergic to penicillin. The example is sulfa-diazine, and another use is to prevent the infection of burns and battle wounds. Example, sulfadiazine and sulfathiazole. Battle wounds means in World War II, this drug was extensively used to treat the soldiers who are having the battle wounds. And another use is useful against the intestinal infection and skin problems. To treat the skin problems, these sulfur drugs were used. So to treat certain forms of malaria, to treat the diseases called ulcerative colitis, and for vaginal infection, and to treat some diabetes. And in combination with this sulfur drug, in combination with antibiotics, many skin burns and malaria could be treated. And another application is the rheumatoid arthritis for reducing joint pain, swelling, and stiffness. And this sulfur drugs were a component of many eye lotions. So these are the important uses. So you remember 2-3 uses that will be useful to you. And another thing we have to concentrate is separation of primary, secondary, and tertiary amines by Hinsberg method. If you have a mixture of amines which is having primary, secondary, tertiary, how do you separate it? So this is a method called Hinsberg method, in which we use a reagent is called Hinsberg reagent, that is nothing but benzene sulfonyl chloride. Benzene sulfonyl chloride is known as Hinsberg reagent. And after treating with Hinsberg reagent, we have to alkaline the solution with aqueous potassium hydroxide. The reason behind this method, principle behind this separation method is, here the primary, secondary, and tertiary amines react differently with Hinsberg reagent. So that is being utilized here. If the primary amine, if you have a mixture which is having the 3 kind of amines, so in the mixture, the primary amine in this way. Primary amine will react with benzene sulfonyl chloride, and we get N-alkyl benzene sulfonamide. Then we are treating with aqueous potassium hydroxide. You get a potassium salt. A salt will form with potassium that is soluble in water. Okay, so we get a soluble potassium salt after treating with benzene sulfonyl chloride, that is Hinsberg reagent. So primary amine will form a soluble potassium salt while reacting with Hinsberg reagent. Now, how the secondary amine will react? The secondary amine is reacting with the same Hinsberg reagent. You get N-dialkyl benzene sulfonamide, but that is insoluble in KOH. Here we could react with KOH as soluble salt was formed, but secondary amine will not be soluble in KOH. It will not react with potassium hydroxide. We get only N-dialkyl benzene sulfonamide. Now, tertiary amine will not react with even Hinsberg reagent. So these are the 3 ways the primary, secondary, and tertiary amines react. And the reaction mix. Now what we will do? We will mix the or treat the reaction mixture with diethyl ether. We have a mixture of primary, secondary, tertiary amine. We have mixture with Hinsberg reagent, and we have the reaction mixture. Now we will mix that reaction mixture with diethyl ether. In the diethyl ether, what happened? The insoluble tertiary amine that was having no reaction with the Hinsberg reagent, that is unreacted, that is there in our solution. So that insoluble tertiary amine and N-dialkyl benzene sulfonamide, that was from secondary amine, that also extracted to ether layer. So both were having both were insoluble in water. So those 2 components will come to the ether layer, and water soluble potassium salt that was formed from primary amine will remain in the aqueous layer. And this ether layer is separated from the aqueous layer. Now here separating funnel we have 2 layers. One is ether layer and one is aqueous layer. In the ether layer we have tertiary amine and N-dialkyl benzene sulfonamide, and in the aqueous layer we have the potassium salt of N-alkyl benzene sulfonamide. Now we have to recover it. We have to separate the primary, secondary, tertiary amine. So how do you recover the primary amine? The aqueous layer is acidic. Aqueous layer is having the N-alkyl benzene sulfonamide that we are acidifying with dilute HCl to get N-alkyl benzene sulfonamide. This is the potassium salt formed from the primary amine that we are separated to aqueous layer. Now that we can remove from the separating funnel, that is just simply react with dilute HCl. You get N-alkyl benzene sulfonamide. That N-alkyl benzene sulfonamide, if you treat with concentrated HCl, we get primary amine and benzene sulfonic acid. So primary amine we could separate in this way. Sorry, this is primary amine hydrochloride. That primary amine hydrochloride, if you react with NaOH, then you get ultimately the primary amine. So you got the primary amine from the mixture. Now we have an ether layer which contains tertiary amine